Alright, it's like almost 10. I have to make a video. First, this camera's been having some trouble focusing. Focus here, camera. So, the question is, if there's, first, where's the edge of my, if there is some light, some parallel light coming in from some angle, oh, you can't see that, I need a better pen. Okay, if there's some parallel light coming in somewhere, from somewhere to somewhere, and we want to focus it back to a point, so we want it to go forward, hit some surface, and focus back to a point. What is this surface? So again, let's just simplify it. We'll say directly horizontal. So horizontal incoming rays, they should reflect off some surface. You know, we don't know what the surface is yet, or at least in theory we don't. It's a pretty well-known surface. And we want the light to reflect back to a single point. So what is this surface? Now, the first thought that I had was the position of the surface doesn't really matter. You know, maybe the surface is here. Maybe the surface is over here. These pens are still bad. We'll keep switching pens until we find a good one. So all that really matters is the angle of the surface. All that matters is that any light ray coming in reflects off the surface and goes to the focal point, no matter where the light ray hits. So what we really care about is the slope of the surface. So that immediately brings to mind calculus, right? Derivatives. We're also concerned with, or we care about this working for any angle. So, like if light comes in from up here, we want to find what curve will bring the light to a point. If light comes in from over here, same thing. We want to find what this curve is. So the fact that we need it to work at any angle suggests circular coordinates, polar coordinates. So that's r theta not x, y. Okay, so with calculus, let's the idea is to start this by saying, what can we say about a single point, and how does that point change? Yeah, I guess not how does it change, but yeah, you could say how does it change. You know, that's what calculus is about, all about small changes. So let's say we can find this point, we can find this exact angle, and then we learn how it changes. Let's say, you know, maybe like right now it's going this way, but then over a little bit over here, a little bit upward, now it's going slightly more inward, it's going this way, and so on. So that's, again, just the calculus intuition. Alright. Okay. Alright, finding the slope itself probably isn't that hard. This is theta, then this is also theta, which means this right here is theta over 2. Which means extending these and this and this. This is 0, this is theta over 2 right here. And this is the same, right? This is the normal line, normal to this. So the slope of this is going to be like theta over 2 plus pi over 2. The slope of this, like the absolute slope. Is that even helpful? Maybe not. Now, more importantly, how does this? So like, if we can find this one slope. Let's say you give me a random r, and I'll tell you a random r theta, right? And I'll tell you the angle of this. And honestly, here it only depends on theta. So you give me any theta, and I can say, okay, the slope of this is going to be however you want to define it, like theta over 2 plus pi over 2 or something. So theta plus pi over 2. That would be this slope. But how can I smoothly connect this point to all the other points? By calculus. So I just need to, if I figure out how it changes, how the slope changes, and then I can integrate, whatever, the whole point of calculus. So now we have to ask me. I might have to redraw this whole thing again, but bigger. How does the position of this change? How does the position of this change with a small change in theta, right? Let's draw it out. Where's that? Where's this? Under this. So this is the x-axis. It's not very straight today. This is theta. The slope is whatever, same thing. There's that same normal, or that same whatever. This is the surface right here. This is the infinitesimal part of the surface. Here's the incoming ray. This is r. This length is r. Is it a vector? Maybe. Who knows? Again, I think probably. Do we have to draw the other things? Who knows? Now, d theta, is supposed to be infinitesimal, so it looks a little bit bigger than infinitesimal. So this is d theta right here. D theta, that's kind of visible. Then, because this whatever slope sticks out a little bit, it's like this infinitesimal segment sticks out a little bit. This would be dr. And this little thing would be r d theta, right? I messed this up before, but it has to be r d theta because, as r goes further out, d theta, or this length gets bigger, right? If r is twice as big, whatever. Hopefully you guys know. This length right here is r d theta. This length right here is dr. I think gotta check something real quick. Alright. So now, dr d theta. What is dr d theta? Well, why dr d theta? Because we want to be able to integrate it. We have dr, right? We can probably find this, geometrically it's something. D theta is also something. If we want to integrate, probably like integral of something dr equals integral of something d theta. Yes, that does sound right. So how are all these things related? Okay. For real. We have to. Let's say dr d theta. What is dr d theta, right? This is an actual question. Dr d theta. What is this, right? Dr. Well, this is not a good question. Never mind. Forget this question. How are dr and d theta related, right? Dr d theta. Or no. Here's the real question. What is dr d theta? Okay. So we have dr d theta right here. This is sort of just a definition, right? Dr is this infinitesimal change in r. D theta is infinitesimal change in theta, with this factor. But what are these in terms of things that we actually know? So theta is presumably given, right? We know theta. We know r. What is this in terms of r and theta? All right, I think we're back on track. This is kind of big. Maybe I'll just zoom out a little bit. So dr, what is this? Dr is this small bit here. Theta is this bit here. So, we have two sides of a triangle. This is like probably a right angle. Probably can approximate it as a right angle. What is the side of the triangle? This is, I don't know, something else. Oh my gosh. Okay. So, dr d theta, let's consider like this angle maybe. Right here, this small thing. Alright, gotta zoom in. Alright, this angle right here, right? This is, remember, oh my gosh. Whoops. We're right here. Zooming in to right here. Oh my gosh. Here we go. So, this little angle right here is, it's tangent, tangent of dr over r d theta. So this little angle, maybe we'll redraw it over here. We got just redrawn triangles over and over again. How big is this? This side is r d theta. This side is dr. This, we'll call it alpha. So what is tangent of alpha? Tangent of alpha equals dr over r d theta. Okay, that's a good little relationship there. It's helpful probably. What is alpha? So alpha is this little line right here, right? Alpha. What is alpha? What is this angle? All right, my camera has it says 3 minutes of storage, whatever recording left before the storage is full. So let's see what we can do in that much time. Okay, we'll just redraw this one more time. Boom, boom. Incoming rays, infinitesimal That's honestly worse, but whatever. Extend these rays. This is theta. This is d theta. This is horizontal. This line, as we found somewhere around here, has an angle of theta over 2. I guess like what angle would it be? It would be maybe we'll have to redo this. This line has an angle of theta over 2 above the horizontal because it's the reflecting point. So that means, and then this is also theta over 2 because of the way it is. Which means this, yeah, this is theta over 2. This is theta over 2 plus 90 degrees plus pi over 2. But that's like pointing backwards. It's kind of awkward. What is this angle? All right. I went in and deleted some more some old videos. Now we have another 20 minutes. Okay, where were we? Negative theta over 2. This is like angles don't really are angles negative. Is there such a thing? Is that correct? Let me see. Okay, that seems fine. So we'll theta over 2, right? What was theta over 2? Theta over 2 was this angle, which was this angle, right? Alpha. So alpha equals theta over 2, and it's also negative, right? That's maybe it's important, maybe not. Who knows? I'll try ignoring it. I'll delete this part of the video if it turns out wrong. Okay, alpha now equals, this is like big boy alpha, right? We'll call it A. We'll call it capital alpha equals theta over 2, right? Where's the other thing? And up here, tangent of alpha equals dr over r d theta. So up here, we'll just say a is defined to be the absolute value of alpha, just to be formal. Tangent. Okay. We have tangent of A, alpha, big alpha. I think that's how you write big alpha. Equals. Maybe rotate the paper a bit. dr over r d theta. Now that is a differential equation. Let's rewrite that over like here. Focus. Right here. Okay, good. Tangent A equals dr over r d theta. Beautiful. Move the r d theta to the other side. Wait, did I say r d theta? Is it dr over d theta, or was it tangent? It was dr over r d theta. Yes, it was that. Let me check. Wait, why am I still writing A? A, we can just write it as theta over 2. And bring the thetas to one side, so tangent of theta over 2, maybe it's negative theta, who knows? d theta equals dr over r. Classic stuff. Integrate tangent of theta over 2 d theta equals integral of dr over r. Okay, what is the integral of tangent? No clue. We'll just wait. Tangent is sine over cosine, right? So integral of sine of theta over 2 over cosine theta over 2 d theta equals this we know, right? Ln r plus c. What does the constant here represent? Not sure. Plus c. This, let's just add more paper at the bottom, perhaps. U equals sine theta over 2. Du equals cosine theta over 2 d2, nope, over 2. Du equals cosine theta over 2 d theta over 2. Let's give it some space. Where are we? Oh, someone calls. Wait, Concordia. Good. Here, sine blah blah sine theta d theta equals is correct. Cosine theta d theta. No, there's no cosine theta d theta. This is wrong. This is not correct. That was the incorrect choice of u. Let's choose another u. U equals, oh, this pen is squeaky. U equals cosine theta. Cosine theta over 2 du. Oh, du equals negative sine theta over 2 over 2 d theta. Alright, this is looking better. Okay. Sine theta over 2. Sine theta over 2. Okay, so we need to put this in here. So let's put a negative 2 in the front. Whoops, this is a little bit too low. Let's give some more room. Negative 2 integral of negative 1 over 2, right? These two cancel out, of sine theta over 2 over cosine theta over 2 d theta. Okay? Du is negative, well, now it's kind of hard to see. Du is negative 1/2 sine theta over 2 d theta, which is right here. U is cosine theta over 2. So this equals negative 2. This is, by the way, the negative that I confused about. That's what that is. I was thinking that this negative like carries through to here, but no. Angles, in fact, are not negative. Negative 2 integral of du over cos theta over 2. Wait, this is what is this? This is wrong. Is what it is. Du u equals cosine theta. This should be u, right? This is all bad. Bad. That's what it is. It's wrong. We have u goes to here. Du goes everywhere else, right? So now we have negative 2 integral of du over u. Yes, equals well, what it equals is negative 2 ln u plus c2. And this equals this, which is this, ln r plus c. Now these c's, I don't know what the interpretation of them is, so I'll just cancel this out and call this C3. C3 is defined to be C2 minus C1. It's not really important, but okay. U is cosine theta over 2, so this becomes negative 2 ln absolute value cosine theta over 2 plus C3 equals ln absolute value r plus c, nope, not plus c, just r. Let's put r on one side. Okay, r is almost already on one side. Bring it to this side just to make it better. And r, can r be negative? Honestly, don't know about that about polar coordinates. Maybe someone could tell me. We have ln r equals whatever that equals this still. That's an r, by the way. Raise both sides to, or e. Well, can't record this. Exponentiate both sides. Yeah. So we have r equals e to the power of negative 2 ln absolute value cosine theta over 2. Maybe I shouldn't have called that parentheses, plus C3. Now that is an expression. Is it a good expression? I don't like it. Simplify a little bit. Equals negative 2 can be brought into the logarithm. E to the ln absolute value cosine squared theta over 2 equals absolute value plus C3, proper parentheses this time, equals C3 equals I guess, yeah, expand it out first. We'll expand it out up here. Equals e to the ln absolute value cos squared theta over 2 times, or no, yeah, times e to the C3. We'll call e to the C3, define that to be C4. That's the C right there. Then over here the E ln cancels out. The squared, wait, I didn't close the absolute value. The squared on the cosine also makes it so that the absolute value is redundant, so I can ignore that. Equals cos squared theta over 2 plus C3 r equals that. That is an expression. I think it's a pretty... Is that even correct? No, it is not. It's not correct. The exponent is wrong. That should be -2. This should be -2. Whatever. This should be -2. Okay? So this is good. This is... and then this... Is that C3 still correct? No, that should be times as well. This should be times multiplied by. This is a multiplication dot. So it's r equals 1 over cos squared theta over 2 C3. Alright, now this could be... I don't know if it could be simplified further. I mean, you can move it around a little bit, but I think this answer is fine. Well, that light's a little bit bright. Oh, that looks good. R equals 1 over cos squared theta. Do they have theta in here? Theta over 2. And then what is there? There's C3 over here, C4 over here, whatever it was. It was C4. And we said that we can just offset it by adding something to the theta, so add plus A. So we can rotate around by changing A, and we can adjust the focal point. So that it always, I mean, the whatever this is the distance, it always focuses at the origin. But we can adjust the focal length, I guess, is the... And look, C4 is the focal length. How beautiful is that? And this is, I mean, what shape is this? That's a good question. Can I prove it's a parabola? Maybe, but that shows it good enough. So these two curves, where are they? Overlap is the same curve. Oh my gosh, gotta zoom out a little bit more. I mean, I could just record my screen, but yeah, so it's a parabola, as we all expected.